There's quite a lot to cover in this lecture, because it's essentially trying to present in under an hour what is actually quite a complex directive. It includes a lot of different aspects. What I'm going to be covering is the context behind the directive, the scope, what's included within it, something about the history, about how it happened, the regulatory development process that's used to actually develop regulations, and the methodology that's also deployed for devising the regulations, quickly discussing which products are currently regulated and which are in the pipeline, then summarizing the expected benefits from the directive, and then lastly talking about the monitoring, verification, enforcement processes, criticisms that the directive's received, and the future direction and gaps and next steps. So just to briefly summarize the overarching policy goals that the European Union has regarding energy and greenhouse gas emissions targets. Underpinning the EU's energy policy, as is true in most economies, are the 3 E's, which are energy security, economic efficiency, and the environment. The new Commission's recently published Energy Union paper talks of having a more integrated, secure, competitive, and sustainable European energy system, and of which energy efficiency is at the heart of it. And prior to this, the EU had already set itself a target of 20% energy savings by 2020 when compared to the projected energy use in 2020, which would be roughly equivalent to turning off 400 power stations. It had also targets of 20% reduction in greenhouse gas emissions and 20% increase in energy supply from renewable energy. In other words, 20% of all energy supply should be from renewable energy. And those are legally binding, but the energy efficiency target isn't. And at the EU summit in October 2014, the ministers agreed on a new non-binding energy efficiency target of 27% or greater by 2030. So those are the broad policy objectives. To help meet those objectives as regards energy efficiency, there are 4 principal directives. There are other directives like the Emissions Trading Directive and the IED Directive, which have some impact on energy efficiency, but these are the dedicated directives which are concerned with energy efficiency. There's the Ecodesign Directive, which I'll be talking about further today, the Energy Labelling Directive, which is strongly related to the Ecodesign Directive. There's also the Energy Performance in Buildings Directive and the Energy Efficiency Directive, which is a more transversal directive. All issues concerning transport are actually addressed in other regulations, which are not actually managed by DG Energy. But the Ecodesign Directive, as you can see from this graph, ostensibly covers 3 sectors, which is the residential, services, and industrial sector, but it specifically relates to products used within those sectors. Whereas we can see that some of the other measures, like energy performance in buildings, obviously just concerns the residential and services inherently, and ETS and the IED concern industry specifically. Now, an energy-related product is defined as any good which has an impact on energy consumption during use, which is placed on the market and or put into service. And the directive provides for the setting of requirements for energy-related products covered by implementing measures. And these are the requirements that the products have to satisfy in order to be placed on the market and put into service. And the most important of these requirements are minimum energy performance standards, or MEPS as they're commonly known. And most of the implementing measures within the directives actually concern this. So they're essentially requiring the product to meet a minimum level of energy performance. Now, this contributes to sustainable development, obviously by increasing energy efficiency, and also the level of protection of the environment, because other environmental factors are also can also be regulated through these implementing measures. And it obviously helps to improve the security of energy supply. The level of eco-design requirements has to be established through a basis of technical, economic, and environmental analysis informed by the best performing products or technologies available on the market. In fact, as I just mentioned, the implementing measures are not constrained to just energy in use, which would be what you would be typically covering in a minimum energy performance standard. They are actually derived from considering all the environmental impacts of the products over their life cycle, from cradle to grave. And these include all the different stages shown in this figure, so the resource extraction and processing, the design, the manufacturing and retail, distribution, use, collection, and the end-of-life stage is the reuse, recycling, energy recovery, and disposal. In practice, however, most of the regulatory requirements concern energy in use, and to some extent other parameters like water consumption or noise or other environmental factors associated with the actual use of the product. Now, to discuss a little bit about the history of the development of minimum energy performance standards shown in this graph, of which, as I've mentioned, Ecodesign is Europe's principal instrument to introduce. We can see that actually the European Union was the fifth economy to start to introduce minimum energy performance standards for equipment. In fact, individual member economies of the EU, most notably France, had actually had some minimum energy performance standards in the 1970s, and that we think there was one possibly in Poland in the 1960s. But the EU as a whole first introduced them in 1992, but the Ecodesign Directive, the first version of it, was issued in 2005. So there was quite a gap before this directive came into effect from when the first minimum energy performance standard was actually implemented. And you can see here the timeline. On the top bar, you can see the timeline for the energy label, and on the bottom bar, you can see the timeline for Ecodesign and minimum energy performance standards. So the first MEPS were set for boilers in 1992, and then they were followed up some years later in 1998 for MEPS for refrigerators, and then one for ballasts. And then there was a period where there was no further regulations imposing minimum requirements, but there were a number of negotiated agreements with different industry sectors. And then finally in 2005, the Ecodesign Directive was actually published. Now, this is it's actually a framework directive, which means that it gives broad authority to introduce regulations within it for a whole range of different energy-using products. And prior to that, as you can see in this graphic, that the previous MEPS, which had only concerned energy performance, had just been set for individual products, and each one of those required a specific directive to be issued with the same sort of degree of legislative burden as if you were issuing the Ecodesign Directive itself, but obviously a lot less impact because they only concerned an individual product. The original 2005 directive was then modified in 2009 to change it so that it became applicable to energy-related products rather than just energy-using products. And that enabled products which have an influence on energy consumption but don't directly use energy themselves to also be brought under the purview of the directive. So that might include things like shower heads or taps or windows, for example, or insulation. You could, as I've just indicated, there was quite a delay before the EU finally adopted the Ecodesign Directive from having its first MEPS, and it came long after the adoption of a Framework Directive for Energy Labelling, which happened in 1992. And I think it took a while for policy makers within the EU to understand quite what was at stake and how much benefit they could have from actually having framework legislation which allowed them to introduce regulations applicable to a broad range of products. And one of the inputs to this, which had quite a large impact at the time, was this publication from the IEA called Cool Appliances. which essentially clarified the value proposition underpinning the need for a framework directive on product energy efficiency. And it only looked at residential electricity consumption. It wasn't just focused on Europe either. It was looking at all of the IEA economies. But it demonstrated that there was a savings potential of 38% in residential electricity demand from, while at the same time having net economic benefits for the economy. And that was the first time that there'd been an analysis showing quite how much energy could be saved through these kinds of measures, and was a significant catalyst towards the introduction of the Ecodesign Directive 2 years later. This shows the legislative process that's followed in Ecodesign. Essentially, the first part is the development of a working plan. I'll discuss that, what's happening most currently with that towards the end of this presentation. And then after, the working plan basically sets out which products are going to be investigated in the coming couple of years. Once those products have been settled upon, then a process of undertaking preparatory study is initiated. And you can see the timelines here. It typically takes about 4 months for the Commission to actually contract entities to conduct a preparatory study. And the preparatory study is then done by consultants in an open consultative process with input from all interested stakeholders, and with publicly available material published on websites, open stakeholder meetings, etc. And I'll discuss what's in those preparatory studies in the following slide. But this typically takes about 20 months to complete. And then there is discussion about the findings from the preparatory study at the consultation forum, where representatives from member states and other interested parties will discuss the value proposition, and they will also discuss potential draft measures which have been put forward by the Commission. So these would be draft implementing measures which may well include minimum energy performance standards. If this looks like it's going to progress, then an impact assessment will be conducted, which will essentially determine what impacts would be expected were the draft measures to actually be implemented. And then it will be taken to the Cabinet inside the Commission for inter-services consultation. There are three parts of the Commission which are most engaged with the development of Ecodesign implementing measures. They're DG Energy, or DG Energy and Climate, as it now is, DG Grow, or former DG Enterprise, and DG Environment. And they are all involved in this, and they obviously have, each of those parts of the Commission will look at the proposed measures and convey their views within this inter-service consultation. There will also be a need to notify the WTO, and as it happens, these kinds of measures are actually the largest form of notification to the WTO. They've now become extremely common, not just in the EU, but globally. And then you can see, in the middle section, you can see actually the process which would be followed for an Ecodesign Implementing Act. It would then be passed to the Regulatory Committee comprised of representatives from the Member States for a discussion and vote. If it passes through that, then it then goes to the European Parliament and Council for scrutiny, and then adoption, and then publication in the official journal. So you can see from this, it is quite an involved process, typically taking 40 to 42 months, and a lot of different consultation involved. In order to derive a minimum energy performance standard or an energy label, there are a hierarchy of technical needs which underpin them. And at the bottom of this, and in some ways the most fundamental part, is the development of test methodologies which can be used to actually measure the energy consumption of products, but also parameters which are related to their energy efficiency, for example, like capacity, and other parameters which might be relevant as well for implementing measures, which are not just concerning energy performance, but also factors like water consumption, noise, etc., other elements which could find their way, quality factors which could find their way into the requirements specified in the implementing measure. And each of these requires test methodology to be established in order to do that. And these are developed in Europe through the standards bodies CEN and CENELEC. Once you have a means of actually measuring the performance of different parameters, you then need to determine your product categories. Which products are going to be treated in the same way as each other when you come to defining an energy efficiency metric. And those metrics, which would ordinarily be specified in the implementing measure, will indicate essentially how the performance is to be evaluated, the energy performance. So it will, efficiency measure is a measure of the energy consumed per useful service provided. So you have to be able to measure the energy, as I've mentioned, and define the useful service. And this clearly relates back to the product categories, what is going to be included in the same methodology for defining efficiency metric, and hence what products are considered to be providing the same service. And once you've got all of that, you can then see how the products on the market actually perform, what the distribution of efficiency is. And on top of that, you can then analyze how much further improvements could be made from either the best available technologies, deploying all of those, or even the best not yet available technologies, but doing some investigation into what is theoretically possible from deploying more advanced technologies than are currently being deployed. And from that, you can get a sense of where the market currently is, where it could be, and make a decision about the actual performance thresholds which would be included in a regulation. Now, the whole process of developing this, or the Ecodesign implementing measures, which has gone through in the preparatory studies, is set out in something called the MEErP, which is the methodology for energy of energy-related, or eco-design rather, of energy-related products. And it essentially follows the tasks set out in this graphic here. Sometimes there is a sort of pre-task called a quick scan, which is sort of, classified as task 0, where a number of different parameters will be assessed. But in all cases, you would then go into these other tasks shown here, where you would assess the scope and all of the available standards for measuring energy performance, for example, and other relevant factors in task 1, and then you would look at the markets for the products, where they're sold, volumes, etc. in task 2. Task 3, you would look at how the products are used and the users of the products. Task 4 looks at all the different technologies which are available. Task 5 then pulls this all together to establish a base case products which are considered to be representative of typical products on the market currently. And for those products, there will be an assessment or a life cycle analysis, which essentially look at all of the different environmental impacts that that base case product would have, from cradle to grave, and a life cycle cost analysis, which will look at the life cycle costs associated with the purchase or the acquisition and use, and then post-life of the product. And then this is followed by task 6, which looks at the design options to see how that base case product can be improved. And as I mentioned, they can be based on existing products which are superior on the market, or existing technologies which are would lead to higher performance on the market, but also can be looking at technologies which are not yet on the market but could be on the market. And then finally, this is all pulled together in a set of scenarios in task 7, which analyze essentially what could be the macro benefits from moving to higher design options or higher performing products. And you can see an example of the life cycle cost approach shown in this graphic here. You have life cycle costs shown in the vertical axis in euros, and they're comprised of two elements. One, which is the purchase cost, shown in the green line here, and the other one is shown in the light blue line, is the operating costs, which are principally the energy costs. And when you add those two things together, you get the life cycle cost. Now, you might go from a product which is label class E to, say, a B or an A, and you would be improving the energy performance and hence producing energy savings, as shown in the x-axis. But in so doing, you're deploying higher efficiency technologies, which at a certain point will start to cost more to deploy, to use, and hence they will drive the costs up. And at a certain point, you will reach a minimum in the life cycle costs. And this is where, under the provisions of the Ecodesign Directive, the implementing measures need to set their requirements. So the minimum requirement is set at what is derived to be the least life cycle cost, which is shown in that vertical line in the middle of the graph here. Now, it's interesting to consider just how many products are actually addressed by this directive. This is essentially a map of the energy consumption of the European Union. You can see in the bottom left-hand wedge that that's all of the electricity consumption in the European Union on the second circle. And then in the red, you can see all of the heat energy consumed in the European Union, or heating fuel consumed. And above that, in the top, you've got transport fuel. You've got energy losses on the top left, which is essentially associated with production of electricity and thermal power plants, as the losses from those. And you've got a certain amount of energy being used for feedstocks in industry as well, in a very small wedge. But all of those electricity and heating fuel consuming end uses are then broken down in the rest of this figure. And you can see it's a map from 2007 showing estimates from that time of how much energy is being consumed in each one of these different end uses. Now, when we overlay, this is somewhat out of date, but it gives you an impression of it, the coverage of eco-design, preparatory studies and implementing measures against this consumption. You can see here that what the state of play was in January 2011. And at that time, most of the products were either subject to implementing measures or they were under development, as is shown here, on most of these end uses. So it's a pretty impressive array of coverage of energy consumption in energy-related products so far. All of these different products are currently subjected to implementing measures under the Ecodesign Directive. And some of these are extremely challenging products, like you have network standby, which is very difficult to define and then to actually impose requirements on. You have very ambitious products like space heating equipment, where you would find in other economies that you might have regulations for boilers, for gas boilers, or you might have them for some other kind of space heating equipment. But you will rarely find a measure which is specified for all space heating equipment, as is the case for the EU. And so although this list doesn't look massive, it's actually covering a very large amount of energy consumption. In each one of these directives, there is a lot of different sub-products subject to the measures that are actually put forward. This figure here shows the products which are currently in the pipeline. So there's 17 more, is it 17? Or maybe it's a bit more than that actually, about 21 I think, products which are actually pending or preparatory at various stages in the Ecodesign pipeline. Now, not all of these will lead to implementing measures. The fact that it's being investigated doesn't necessarily mean that a decision will finally be made to have an implementing measure. But very often they will, and so this gives you a sense of what is likely to come in the future, looking at the list of products here. And here we can start to see some non-energy related products, such as, energy related but not energy using, such as windows are in here. And so far there are actually no measures that are applied to non-energy using products, but that may change at some point in the future. So I mentioned that there is a considerable breadth in the way that the EU has applied these measures to different products. And ostensibly, they've taken an approach by which the end users are assessed by their service provision or functional level. And any end user technology which provides the same functional service could then be compared to any other one which provides the same functional service. So that means that there isn't a separate requirement for, say, incandescent lamps and compact fluorescent lamps. It's just for domestic lighting. And that therefore allows those technologies to kind of compete with one another and can actually lead to greater savings than where you would isolate them and just require efficiency improvements, say, amongst CFLs or amongst incandescent lamps. And some of the areas where the EU has broken quite a lot of ground, and there's many of them in this directive, they introduced a 1 watt standby power limit across all products so that no product placed on the market could consume more than 1 watt of standby power. And other economies have tended to regulate the individual products and set specific standby limits for those products. And the EU has some of that as well. So this is a kind of horizontal minimum requirement, but it may be for some individual products that there is a separate Ecodesign implementing measure which would require the standby power to be even lower. The requirement for electric motors is also very interesting because rather than just imposing a pure minimum energy efficiency requirement on individual types of electric motors, it actually sets a slightly less stringent requirement if you sell the motor with an integrated variable speed drive than if you don't. And there's actually much greater savings to be achieved from using power load modulation through variable speed drive technology than just from improving the efficiency of the motors, although both of them are absolutely recommended. The fans directive is another interesting one because the sheer range of different types of fans that it covers, going from as little as 150 watts up to 500 massive industrial fans at 500 kilowatts. And the lighting directive, as I mentioned, covers all domestic lighting under one implementing measure and ostensibly all tertiary lighting under another implementing measure. Now, behind the idea of having energy labels and minimum energy performance standards is a market transformation concept. And this is a fairly old figure that shows quite succinctly what the principle is. The idea is that with the implementing measures in, say, the Ecodesign Directive, or more commonly known as minimum energy performance standards, that they would tend to push the market, such that if you have a randomly distributed market shown in the red curve here, after you introduce minimum efficiency standards or minimum energy performance standards, you would end up with a figure with a distribution shown, say, in the blue, where you've eliminated those products which don't meet the standard. But there's no incentive to go beyond that standard. Whereas if you combine this with energy labels, they create some pull in the market because there's an incentive to actually achieve much higher efficiency levels. And then you might end up with a distribution as shown in the green curve here. And over time, you can use this push and pull to renew your minimum energy performance standards and to push again, and to renew your energy labels and to pull again. And so the market should continuously transform towards higher efficiency levels in response to these two policy instruments working in tandem together. And we can see an example of this when we look at the evolution of the refrigerator market. This figure's a few years out of date now because it only shows the state of the market up to 2011. But you can see how the market was in 1993, just when energy labeling was first introduced. Then the minimum efficiency standards were introduced in 1998. They didn't eliminate all of the D, E, F, G classes. There were still a few types that were allowed in D and E. And so you can see in 2003 that there's still some residual D and E, but there's clear impact of that minimum energy performance standard. And there's been a clear impact as well from energy labeling, so the two working together. And then the minimum performance standards were renewed again in 2009. At that point, they eliminated the Class A, which had been the best on the market in 1993, and only a few percent had attained that. And then they were renewed again, the MEPS in 2013, to eliminate the A, so that now only A plus and better is permitted on the market. And you'll see that the impact of the label, there are a lot of A triple pluses and A double pluses now, so that the distribution has shifted yet again. And refrigerators are currently under, there is a preparatory study underway for those at the moment. So it's quite possible that new minimum energy performance requirements will be specified through an Ecodesign implementing measure. And this has had a huge impact on the efficiency of these products, which instead of using, well, they would have been using about 140 terawatt hours a year, they're now using more like 60 terawatt hours per year across the EU. We can also see the basic value proposition in this figure as well. One of the earlier products to be regulated was lighting, in domestic lighting, as I mentioned, and an implementing measure was adopted in 2009 for that. And this figure shows that ostensibly the losses you incur, unfortunately this IRR box in the middle is covering it up a little bit, but if you have 100 units of energy going into a standard thermal power plant, you'll lose 62 units in the power plant in losses, and then transmit 38 units into the entering the transmission lines, and you'll lose at least 2 units in transmission and distribution losses, maybe more. And that giving you 36 units actually entering the house as power to go to an end use. If you then put it into an incandescent lamp, which has an efficiency of 5%, in other words, 95% of electricity going into it just produces heat, and only 5% produces light, then you end up with a total efficiency of just 2% for the entire process. Going to a compact fluorescent will quadruple the performance. You'll get 8 units instead of 2 for your original 100. And if you go to the best LEDs available now, then you'll be getting more like 20 units compared to the 2. And just using the compact fluorescent lamp itself has an incredible rate of return against an incandescent of well over 180%, which is a pretty good investment by anybody's standards. And so this basic value proposition has underpinned why there's been so much savings that have been possible through eco-design type implementing measures. In the case of incandescent lamps, EU heads of states adopted a policy to phase out the lamps in March 2007, and the eco-design regulation was issued in April 2009, in a number of different provisions. And this was part of, it wasn't alone, but the EU was definitely one of the leaders in the global move to phase out incandescent lamps. And subsequently, almost all the economies in the world have now moved to phase out incandescent lamps. And this was interesting because, apart from anything else, it shows the global scope of these regulations. One of the issues which had to be looked at was the impact that the EU and the US's decisions to phase out incandescent lighting were going to have on the supply of available technologies, in particular substitute technologies, in particular compact fluorescent lamps. And so in the end, analysis showed that it would be beneficial if the phase-outs were slightly staged between the three, or phased between the 3 major economies in the world, the EU, the US, and China. And that's exactly what happened. And as a result, we ended up with a relatively smooth progression in demand for compact fluorescent lamps, as opposed to having a huge spike and then crash, which could have actually led to some major supply issues, which was happily avoided. But it's just an indication about how what goes on in Europe can have a much larger global impact than just within the EU itself, and often will require cooperation amongst regulators to ensure that there are no major problems on an international level. Now, in terms of the actual projected impacts from the eco-design policy as a whole, directive as a whole, a study was done by Van Hostan and Kemner in 2013, which shows the figures I'm about to show you now. And you can see that they are projecting that the measures which had already been adopted at that time were on course to save 39% of European residential electricity consumption by 2030. I was pretty interested to see that figure because it was almost exactly the same as the 38% that was projected in the analysis I did in the cool appliances study. So it's sort of reassuring that they seem to be producing similar results. But it would be extremely good news, of course, if this figure is actually realized. But that is the current projection. Also shown in this figure is across all sectors subject to, and all end uses which are actually subject to Ecodesign requirements, how much would be saved in primary energy terms. And it's not just residential electricity, it's also other fuels in the residential sector, it's in the service and commercial sectors, and in the industrial sector that products are concerned. And overall, of all the products that are being subject to the requirements, the expectation is that their consumption will be reduced by 19% by 2020 and by 32% by 2050 with just the existing measures which have been implemented or have been as of 2013. Some more have been implemented since that time, and as I said, there's more in the pipeline. So these are extremely impressive savings potentials. They have a huge impact on the European economy and on the demand for energy, on energy security, and obviously on the product markets themselves. This is the breakdown showing where those projected savings are coming from end uses. And you can see that space heating is the largest one in here. Water heating also very important, and lighting are the three big ones. But there's also contributions being made from industrial components and from some other sectors. And summarizing all of that, there are now over 30 products regulated which are covering 48% of all EU primary energy use and more in the offing. This is expected to produce net economic benefits to consumers of 110 billion euros by 2020, which is equivalent to, well, it's comprised of gross energy bill savings of 170 billion, with extra acquisition costs for slightly more expensive equipment of 60 billion. So there's a kind of benefit to cost ratio of about 3 to 1. On top of that, it's projected there will be 54 billion extra revenue for industry, wholesale and retail sector, and this will create about 0.8 million extra direct jobs for industry, wholesale and retail, and a lot more indirect jobs with that expenditure which is saved, and 110 billion is actually put into other parts of the economy. And in terms of CO2 emissions, it's about 7% of the 2010 EU total reduction in CO2 emissions by 2020. And as mentioned, these savings and impacts are expected to become deeper by 2030. When we look international alignment on minimum energy performance standards, we see that economies around the EU, particularly those close to it, are starting to adopt similar measures. So Turkey has fully aligned their requirements as part of the accession process. Jordan is in the process of doing exactly the same thing. Some of the North African states are also implementing or in the process of developing, implementing measures which are emulating the EU ones. And there is some similarity in some of the minimum energy performance standards adopted in some of the other regions of the world. But we actually see a lot more alignment of energy labeling and test procedures, as you can see in this graphic, than we do so far of minimum energy performance standards. And it'll be an interesting issue or phenomenon to observe, to see the degree to which other parts of the world imitate the EU's requirements, and also the extent to which the EU imitates those elsewhere. And then there have been some cases of that happening too. But here we can see that at least as regards energy performance test procedures, there is much more alignment, albeit that it's far from perfect. And this is quite important because it means that the basis of determining the energy performance can actually be compared even if the individual specifications are not exactly the same. And hence obviously facilitates trade, but it also facilitates technology transfer and accelerates the rate at which economies are inclined to introduce these measures. So now moving on to market surveillance. There was a regulation 765/2008 which requires EU economies to actually ensure they have effective market surveillance of their markets. And it sets out the requirements you can see here, that the monitoring of products or the member states guarantee market surveillance and monitoring the products placed on the market. The marking documentation requirements have been respected. That products are designed and manufactured in accordance with all EU harmonisation requirements. That the market surveillance authorities have the necessary powers, resources and knowledge to perform their functions. And that procedures are put in place for following up complaints, monitoring accidents. And that market surveillance programs are established, implemented and updated. And that the functioning of these surveillance activities is reviewed and assessed at least every 4 years. So these are obligations on member states. But other than that, how member states do this is very much up to them to decide. Typically, you'll see an institutional sort of arrangement as shown here. So you will have a central government ministry who is responsible for the transposition of the directive, the implementing measures, and provides the input from that country into the development of the policy at the EU level. Connected to them, you'll have a market surveillance authority, a designated market surveillance authority for dealing with the Ecodesign Directive. And they may or may not be the same as dealing with the Energy Labelling Directive. Normally they would be the same. But there's a lot of other directives which also have market surveillance requirements, and so there can be one market surveillance authority dealing with all types of directives, or more commonly several of them dealing with different directives. And then they will then conduct surveillance of retailers, products placed on the market, and manufacturers, and they will commission product verification sampling, sending those products to testing laboratories for verification testing, and then they will also manage the enforcement process. But it's not always like this, and some of the member states divide this up into different functions that may also be done at federal level, at different state level, rather than at the national level, depending on the economy in question. There are a number of challenges to the proper functioning of the market surveillance system. The supply chains may be very complex and encompass more than one country. There can be economic operators located in countries that are different to those where the products are made available, and often outside the EU. Consumers are increasingly, obviously, purchasing products through the internet, so the channels of distribution are changing. A very significant issue is the capacity of the market surveillance authorities and the resources that they have, whether they are sufficient or overly constrained. And for some products, just verifying compliance can be quite technically difficult. In some cases, there may not even yet be officially adopted test procedures, or that it's unclear how applicable they actually are in practice to particularly, say, very large industrial products, which might be very challenging to test. Now, some of the criticisms which are being levied at this directive, and there have been periodically some very high-profile public criticisms thrown at the Ecodesign Directive, not least from the country where I'm from, where the elements of the national press get quite upset about EU regulations in general, and particularly like having a go at this directive. And here's an example from the Daily Mail for their campaign they've been running about this directive, explaining why, explaining that, claiming that the EU is going to prevent products from being sold on the market which are powerful enough to clean people's homes, etc., and encouraging people to buy powerful products before the regulations come into effect, etc. And there's been this kind of, I might call it scaremongering, actually taking place in a number of member states, not just in the UK. And it's one of the things that the Commission and the regulators clearly have to be mindful of, is public perception and the media perception of what the directive is doing and what it's there for. And that it's not seen to be just gratuitously preventing the sale of products for no good reason. I'd say more substantive concerns about the directive concern the caliber of the monitoring, verification, enforcement, the market surveillance and enforcement activities, whether they're adequate or not. The administrative capacity in member states and in the Commission to actually manage all the different requirements under the directive. Budget allocations allocated to these processes, The speed of regulatory throughput has been criticised in the past, although that seems to have increased considerably recently. The quality of the evidence base and the asymmetry of information in the regulatory process that can obviously have an effect on where the actual measures are set, or where the, for example, the life cycle cost minimum is determined to be. There's been criticisms of overly optimistic impact assessments, suggesting that maybe the savings won't be quite as high as is being projected. There is concern in some parties of the choice of the least life cycle cost as the benchmark in the directive for the implementing measures. The lack of weight given to environmental impacts other than the use phase and other than energy is being critiqued in some quarters. Also subject to criticism has been the suitability of product performance test procedures. And of course, you know, recently with the Volkswagen debacle, we've seen the importance of those test procedures on reality and actually whether or not they are fit for purpose or not. And there are also concerns about the influence of lobbying, trying to influence the exact nature of the regulations in maybe less than transparent ways. In the case of monitoring and verification enforcement, there was a class study done in 2012, and this found that across the EU at that time, there were only 80 full-time equivalent staff working on compliance administration in all the 30 EEA member states. And that non-compliance levels were often unknown or unreported, but overall it appeared that about 10% of the energy savings potential from the Ecodesign measures was being lost. The penalties for non-compliance were often very weak and poor deterrence, and that the total expenditure on compliance activities at that time appeared to be just 7 million euros a year, which translates to about 1.4 euro cents per capita, and was only about a 2,000th of the value of the energy being lost from non-compliance. Since that time, there's been a lot more discussion and focus given to market surveillance activities, and there's been a lot more drive towards improving it. There was a review of the two directives conducted, or I say the two directives, the two energy-related products directives, so that's labelling and Ecodesign, and that was concluded in the summer last year. And the Commission has tabled a legislative proposal for a revised energy labelling directive, which includes clarifying, strengthening, extending the scope of the directive's provisions, and also has some wording about strengthening market surveillance. It seems less likely that there's going to be any substantive revision of the Ecodesign directive, although there's been no final decision made about this. There is an ongoing decision about how the Ecodesign directive will work with the EU's Circular Economy Initiative, which is currently very much in the spotlight, and about the contents of the next work plan and which products will be worked on in the next few years. And the products which are under discussion currently, from a study which is done on this and was actually discussed in a consultation forum and meeting recently, are listed here. And we can see that the energy savings potentials are not as significant as they have been for some of the previous products that have been looked at, which is logical because obviously one would imagine that they would have begun with all of the highest energy using products or highest savings potential products first. But there are still products here which can have a very significant impact, in my opinion, not least the building automated control system one, which is the highest on here in terms of the savings potential. And yet there's been no decision yet made about which products are going to be included, and that's being awaited. And there may be some announcements in the next few weeks on that issue. One of the issues that's extremely important about the future of this directive and its current implementation is the degree to which it treats products as systems rather than just individual products themselves. This graphic just shows this very out-of-date graph, but it shows the principle that ostensibly, if you simply just replace the light bulb in the street lamp, you can get a limited amount of savings. But if you require a luminaire an optimized luminaire to be used with an optimized light source, you get much larger savings, as is shown here. And if we were to do this now with LEDs, this is ceramic metal halide, then we get even bigger savings. The current Lot 37 study, which is looking into lighting systems, is suggesting that there are savings from lighting systems across the EU, or savings potentials of about 80% of all lighting energy consumption. And these systems level savings potentials are absolutely huge in some cases. Probably the single most important is from electric motor systems, which, while you might save 3 or 4% from optimizing the motors themselves, you can save typically around about 25% from optimizing the motor systems themselves. And that means particularly using what we were talking about earlier, which is variable speed drives in appropriate context. And overall, that's projected that 10% of all EU electricity consumption could be saved by optimizing motor systems alone. As I mentioned, 80% of lighting, but also from building energy consumption, building automation and controls alone have been projected to offer 22% savings for building energy consumption. And there are considerable savings potentials for HVAC, power cables, and a number of other energy-using systems. Now, currently, the Ecodesign Directive is only being applied to address specific products not sold within a system, with a couple of areas where it started to dabble beyond that, including information requirements for heating systems, for installers to provide to end users, for example. And it is a moot point whether the directive can legally be used or not to apply to these systems. And this is why the Commission is actually investigating some of these a little bit further with for example, the Lot 37 study on lighting systems underway at the moment. But what is absolutely fundamental is that if the directive is not used to produce these savings, that something else is. And this is currently a gap in the EU's energy efficiency policy arsenal that really needs to be addressed one way or the other. So it's a kind of area to watch this space in the way the directive is rolled out in the future, and or whether there are other types of initiatives which might aim to address these opportunities. Complex products are also posing a very significant challenge. A classic example of this is machine tools, which come in all sorts of different types, but they have a number of common components sometimes. Data centers and servers are another. And one option which is actively being considered by the Commission currently is the possibility of developing a kind of modular points approach to help rank heterogeneous products based on the components and the way that they're put together to get an overall ranking, when that could actually be used to specify, in theory anyway, Ecodesign performance requirements in implementing measures. But it's early days in that, but the Commission is starting to do some investigations of this from the technical level. I mentioned as well that there's been debate about whether the policy targets or the efficiency requirements should be set at the least life cycle cost level or beyond that. And there's been some debate about this. You can see here the principle of it as shown in the left vertical line showing where it's currently set, which is the life cycle cost minimum. Some have argued that it should be being set at a level which is equivalent to the average product on the market today, and hence going further over towards energy savings. I think it's important to bear in mind that it's not just a question of where this theoretical line is drawn in the sand, but it's also very much a question of how good these life cycle cost assessments are. And I have a personal criticism of the directive. I would say some of them are not as good as they could be, and there is and as a result, they can be overly conservative, and there are actually more design opportunities that could be done more cheaply than have been estimated, which could actually move that life cycle cost minimum further towards higher energy savings without changing the principle. So I think whether or not there's a change in emphasis of where the nominal requirements should be put at, there has to be real attention put into the rigor of the process and how you actually determine what the life cycle cost minimum is. And one of the things which could be factored into this is technology learning effects. Now, this is currently not taken into account at all. The assessment is done on a static basis, usually based on information which is a few years out of date, which the consultants have available. And then by the time the regulation is actually issued, it might be 5 or 6 years later, it would be highly likely that from technology learning effects that the real life cycle cost minimum, even if it was correctly determined in the first place, has actually moved to a higher level than was actually analyzed or concluded in the study. And we find from technology learning curves all around the world that essentially every time you double the installed capacity, you reduce the cost of the technology associated with that. And so it becomes cheaper and cheaper to have the same level of efficiency. And you'll see typical learning rates, as they're known, of about 20% or something of that kind for energy efficiency technologies. And that could, in principle, could be factored into the regulations to make the least life cycle cost requirement time dynamic and responsive to when the regulation is actually issued rather than when the analysis was done. Some other suggestions in summary of future focus. I mentioned the need to invest in reducing the asymmetry of information and improving the quality of evidence and data. A related need is to improve the analytical tools that are used to estimate the impact of design changes. Currently, there's very few tools that are being used for that purpose. And in some other economies, noticeably the United States, analytical tools to do this have been derived, and that it seems to be a gap in the EU process currently. There's clearly a need to strengthen the investment in monitoring, verification, and enforcement, especially considering it's one of the cheapest means of providing energy services across the whole economy, and really ought to therefore be treated as seriously as supply-side options and be given the resources that the benefits that it would produce would be equivalent to supply-side options. And getting anywhere near those would have a huge impact on the actual quality of market surveillance which is carried out. Means also need to be found to realize the savings potentials from product systems, as I mentioned, either through extending the Ecodesign Directive or developing a new policy instrument. And product performance test procedures really need to be thoroughly investigated and invigorated. There's been a massive process through this Ecodesign Directive since its introduction to introduce more energy performance test procedures to cover the different products being investigated, and that's been fantastic and highly commendable. But it is really time now to go and look at those test procedures and to see whether they are actually fully fit for purpose and whether or not they can be circumnavigated, a la the Volkswagen situation, or not. And this has been a concern for many years, actually, which has been highlighted by what happened with Volkswagen recently. Just to internationalize this finally, this figure is from the latest World Energy Outlook from the International Energy Agency, and it shows how much of energy consumption is now subject to mandatory efficiency regulations on a global level. And it's interesting that they estimate that 28% of global energy consumption is now subject to mandatory energy efficiency regulations like the Ecodesign Directive. Now, as I mentioned, Ecodesign in Europe is covering 48% of all EU primary energy consumption already, and there are other directives as well which would impose requirements. So the EU is obviously has a much higher percentage than this, and I think it has now become the principal trailblazing economy in terms of raising the bar for this. There are many other economies looking to it to see whether they can emulate some of these measures themselves. So developments in the EU will have a big impact beyond the EU's boundaries, not just within the economy itself. And I'll just conclude with this slide, which when I was a boy in the 1970s, I remembered seeing a Sunday newspaper supplement had an image a bit like this one, showing the Earth was about to run out of oil. And this was in the 1973 oil crisis. projections then were showing that the reserves of oil were going to be depleted much faster than the supply was being found, and that by this time, in fact several years prior to this, we'd have long passed the age of cheap oil and we'd be in an era of huge oil scarcity. In fact, that didn't happen, and the main reason why it didn't happen is because the extraction efficiency rates from the oil wells were improved progressively year on year, so that far more oil was able to be drawn out of each of these wells than was thought to be the case in the 1970s. And so they've produced a lot more than was considered to be possible. And energy efficiency is like this, but even more so. It's sometimes described as a renewable resource, because each time you keep improving your efficiency, you find there's more ways you can improve efficiency, and you can keep going back to the same end use and extracting higher efficiency levels, essentially getting more from the well. And so as the significance of this idea for ecodesign is that there's plenty of work to be done to revisit the existing regulations and to keep improving them, and to upping the ante so that there can be higher efficiency gains resulting from that, and also addressing the other resource impacts more thoroughly than has been done in the first round of regulations. So thank you very much. That concludes my slides, and I think we're now about to move to the Q&A session.